welcome back to another video. As you can see, making some gains. Yeah. Anyway, that's the same. Get distracted. Yeah, so this video will be mainly talking about systems. What systems are, what the characteristics of a systems are, and possibly the behavior of a system. So a system is basically a set of things, elements, interconnected in such a way to form a behavior over time. And so immediately from this, you can tell what a system is comprised of. The elements, the interconnection is between the elements, and the purpose of the system, the purpose of the behavior. And so you can't necessarily understand a system based off of its parts, but you can understand the system from the purpose of the behavior formed or observed from the system. And we'll get into that a bit more in a bit. So how do you know that you are looking at a system? So basically, there are a few things you need to be looking for. Are there parts within the system? Can you identify parts? And do these parts affect each other? Do they have some sort of communication going on? And do these parts all together form an effect that is quite different from the effect that was from the individual parts altogether? And then can you also derive a purpose from the system, or behavior of some sort from the system? And so basically, those are ways in which you can identify a system per se. And so from that, we also need to understand what the behavior of a system is, or the characteristics of a system. The interconnectedness within the system is derived from how the parts communicate or form a particular piece of information between each other. For example, a tree during photosynthesis has chemical imbalances happening within the tree in such a manner to form an interconnectedness between the roots and the leaves, so that the roots are able to draw water to the leaves, therefore providing the leaves with water which undergoes through photosynthesis. I hate biology, but somehow I just remember that. And then we also need to understand what happens when you begin affecting change within a system. So if you change the parts within a system, you can't necessarily change the system altogether, but you can affect it to some degree. For example, if I take out the leaves from a tree, although I've taken out the parts, which is the leaves, I haven't actually changed much about the system. The process within the system will still continue, or the structure within the system will still remain intact. But what happens when I change the interconnectedness within the system? And now that would have some effect of changing the system altogether. For example, if I was to change how the roots and the leaves are connected, in that they're not connected to the chemical imbalances, but instead it's a form of ones and zeros. This is just an example. And now what you end up having is a system which you've changed its interconnectedness, you've changed the information flowing within the system. So now the system has changed altogether. But what happens when you change the purpose of a system? When you do that, now you've changed the entire thing altogether. For example, we can consider a football match as a system. And if we change the purpose of a football match from being score a goal to being hurt the next person as much as you can, all of a sudden you have UFC in a huge stadium filled with 22 people instead of the usual football that you get. But essentially, that is what a system is. That is essentially what its structure, its behavior, its characteristics are. And yeah, I'm learning a bit more as I go along, sharing it. Peace.